Hi all, in this video we're going to revise all of the area formulas that you need to be able to recall and use for the GCSE Foundation Tier Mathematics. But first let me remind you all of what you should be doing weekly during this period of self-study. So if you go into SharePoint, there are a set of instructions. There are 4 tasks that I would like you to be doing. Firstly, I'd like you to go to the Corbett Maths website and have a go at one of the 5-a-day tasks. Secondly, there is a weekly Maths Watch task, and again, login details are in SharePoint. Thirdly, task 3, some questions from some worksheets from Maths Watch, also available on SharePoint. And if you get that done, particularly after Easter, there are 3 past papers for you to be working on. So, as I've already said, the first task is to go onto Corbett and look at the 5-a-day tasks. If you go on the website and you click on the link that says 5-a-day and choose GCSE, there are 5 different difficulty levels of tasks. So if you go to today's date, for example, the 30th of March, the numeracy ones are more straightforward, and then foundation plus one of those 3 is what you should be choosing to have a go at. They look like this. Okay. You can also find the answers for each of those sheets on the Corbett website, March Answers. If you get stuck, you can go back to the index at the top and choose videos, and you can search for a video for that particular topic. So for example, this first question here is about simplifying algebra. If you go to the Corbett website and search for the videos, you can find a simplifying algebra video, and I'll show you this one here.
In this video, we're going to look at how to collect like terms. It's very important in maths you're able to simplify expressions. Something like this: a plus a plus a plus a. Well, a plus a is 2a, plus a is 3a, plus a is 4a. So that would be equal to 4a.
And you can see that's quite similar to the first question on the 5-a-day sheet. So don't forget that you can use the videos on Corbett Maths to help you with the 5-a-day. Okay, so today we are going to be looking at area, and the most simplest area shape we can have is a rectangle. So if we look at the first example, we have a simple rectangle which is 5 squares across and 3 squares down. And I want to know what the area of that rectangle is. Now I could just count the squares. I want to know how many 1 by 1 square centimetres fill up that rectangle, and that will give me the area. So I could do something as simple as count them. So there's 1 there, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I could count the squares to calculate the area, and sometimes that's one of the simplest things you could do. The same rectangle, we can think of it as a row of 5, and there are 3 rows of 5, so that could also be calculated as 3 lots of 5, which is 15. Or we could look at the columns, and each column has 3, so there are 5 columns of 3, and 5 lots of 3 is also 15. So there are 3 different ways of thinking about the area of a rectangle, and each of them, the quickest way is to do the length, which in this case was 5, and the width, which is 3, and you can call them base or height, it doesn't really matter, and you multiply those 2 dimensions together. So the area of a rectangle is the length multiplied by the width. So here are 2 different rectangles. Let's look at the first one as an example. It is 1, 2, 3, 4, 5, 6 centimetres across, and 1, 2, 3, 4, 5 down. We use the rule we've just talked about. We're going to use length times width, and 5 times 6 is 30. And they are square centimetres. And it doesn't matter if you do 5 times 6 or if you do 6 times 5. Now's a good time to pause the video and have a go at the question on the right hand side. Okay, so this is 3 squares tall and 1, 2, 3, 4, 5, 6, 7 across, which is 7. So you could have calculated 3 times 7 or 7 times 3, which gives you 21 square centimetres. Sometimes the units are on the answer line. If they're not, there's a mark available for them, so please remember to check to put the units on your answer. Okay, the next type of shape is a triangle. I'm going to go back to the rectangles to help us do that. So if we look at this first rectangle, it is 1, 2, 3, 4, 5 tall and 1, 2, 3, 4, 5, 6, 7, 8 across. And if we want to calculate the area of that rectangle, we would do 5 times 8, which is 40 centimetres squared. Now, there are 3 triangles drawn underneath. Each of those triangles takes up half the space of the rectangle. So if we look at this first one, it is 5 high and it is 8 across, and this line cuts that rectangle into 2 equal pieces. So if we wanted to calculate the area of that triangle, it would be half of the rectangle at the top, which is 40. So this triangle would have an area of 20 centimetres squared. It is half of the rectangle that encloses it. We look at the triangle on the left. Hopefully you can see the same rule applies. The vertex at the top is in a different position, but that yellow triangle takes up half of the area of the rectangle. And again, the rectangle is 40, so that triangle also has an area of 20 square centimetres. The last one does look a little different, but the rule is the same. It has the same base. It has a base that's 8 squares across, and although the vertex is further to the right, it still has a height of 5 units. So it still has the same formula for the area. We would use the base, and we would multiply by the height to find the area of this rectangle, and then we would divide it by 2. So that would also be 20 centimetres squared. So the formula for the area of a triangle is the area of the rectangle that encloses it divided by 2. So we can write the base times the height divided by 2, or we sometimes like to write half the base times the height. So let's look at 2 examples. I'll do the 2 examples on the left. So this triangle here, 1, 2, 3, 4, 5, 6 centimetres across and 1, 2, 3, 4 tall. We're interested in the height of the triangle, not the length of the sloping sides. Remember, we are remembering that that triangle is sitting inside a rectangle. Don't have to draw the rectangle, but it's 6 across and 4 tall. So 6 multiplied by 4 is 24. We've got half of that area, so divide it by 2, and that gives us 12 square centimetres. Base multiplied by the perpendicular height and divided by 2. Look at the next triangle. The base is the measurement from here to here. That is 4 squares from this corner to this corner, and it has a height of 4. We're going to do the base multiplied by the height, and then we're going to divide that by 2. 4 times 4 is 16, and then half of 16 gives us 8 square centimetres. Pause the video and have a go at the 2 questions on the right hand side. Okay, so this top triangle is 1, 2, 3, 4, 5, 6, 7, 8 squares across, and it also has a height of 4 units. So the area of this green triangle is going to be 8 multiplied by 4, and then divided by 2. So we've got 8 times 4, which is 32. 32 divided by 2 gives us 16 centimetres squared. On the triangle at the bottom, 1, 2, 3, 4, 5 across, that has a height of 4, and again it's the height straight from this top vertex straight down to the bottom, perpendicular with the base that we need, not the length of this diagonal or this diagonal. 5 times 4, base times height, and halve it. So 5 times 4 is 20, and half of 20 gives us 10. Okay, the next type of shape you can get is a compound shape. Often these are worth 3 or 4 marks. It is made up of rectangles, and there are a number of ways you can tackle this type of question. One of the things you can do is to take the shape and split it up into 2 rectangles. So I've got a rectangle here, rectangle A, and another one here, rectangle B. Or I could choose to split it across here and have 2 rectangles here, one there and one there, and calculate the area of each of those and then find the total. Or if I really wanted to, I could take this rectangle around the outside, this whole rectangle, and then subtract this missing piece here to find the area of this yellow shape. What we mustn't do is take all the measurements we're given and multiply them together. We must use the fact that we know how to find the area of a rectangle as its length multiplied by its width. So let's have a look at an example. The L shape on the left, we're going to split it, and I can choose to split it across here and get a smaller rectangle there and a larger one at the bottom, or I could go straight down here. I think I'm going to go straight down. It shouldn't matter as long as you are clear. When you're completing an exam question, you can draw all over the diagrams. So I have 2 rectangles, one here and one here. Now this rectangle, I have all the measurements I need. I know its width is 4, and I know that its height is 7. So rectangle A has an area calculated by 7 multiplied by 4, which is 28. I don't have the width for rectangle B. I do know its height is 4, so I need to do a little bit more work to find this measurement. Now I do know the whole thing is 10 across, and I know that this rectangle here is 4 across. So if the whole thing is 10 and this part here is 4, this one must be 6. So it's 10 subtract 4 gives me 6. Now I've got the dimensions for rectangle B. I can calculate B, which is 6 multiplied by 4, which is 24 square centimetres. You don't need to put the units until you get to the very end. The total area for this shape then is 28 at 24, okay, which gives us 52 centimetres squared. So if you'd like to pause the video and have a go at the question on the right hand side. Okay, let's have a look at this second compound area. I'm going to split it into 2 rectangles again, rectangle A and rectangle B. Rectangle on the left, I have the dimensions that I need. I know its height and its width. So rectangle A has an area which is 6 multiplied by 5, length times width for a rectangle, which is 30. I need to find this missing side here for rectangle B. Can't use 12 because that's the distance all the way across. This one here is 5 across. So the difference between 5 and 12 is 7, and that will give me the missing dimension for rectangle B. So rectangle B is 7 by 4. So I can put that in my working out space. 7 multiplied by 4, which is 28, and that gives me a total area of 58 square centimetres. Okay, our next shape that we need to be able to find the area of is a parallelogram. Now, a parallelogram is a shape made up of two pairs of parallel sides. So these two sides here opposite each other are parallel, and the same with these two. That means they're going in the same direction. Also, the sides opposite each other are equal in length. Now, I'm just going to change this parallelogram so that it looks like a rectangle. I've got a base width here, which is 5 in this particular one, and a height of 3. If I take the right-hand side away from this parallelogram, this triangle here, and remove it, and I move it to the other side of the object, I get a rectangle. So the formula for the area of a parallelogram is the same as the one for a rectangle. There's my parallelogram. I haven't changed the total area. It's that pink shaded area. And the height in this particular case is 3 and the base is 5. If I take that triangle over, it makes a rectangle. So the area of a parallelogram is the base multiplied by the perpendicular height, the height at 90 degrees to the base. So let's have a look at an example of how that works. If we look at the base of this parallelogram, 1, 2, 3, 4, 5, 6, 7 centimetres wide. We're not interested in this length of this sloping line. We need the height straight from the base, straight down. So this has a height of 3 centimetres. We treat the parallelogram just like we do a rectangle. The formula is the base multiplied by the perpendicular height. 7 times 3 is 21 centimetres squared. I'd like to pause the video and have a go at the question on the right hand side. Okay, let's have a look at this one. 1, 2, 3, 4, 5, 6, 7 squares across, and its height, again, we can either draw that on this side or we could draw it on here. We want the height straight up, 1, 2, 3, 4, 5 units. We do not want this diagonal length. We treat it just like a rectangle. Base is 7, height is 5. 7 multiplied by 5 is 35 square centimetres. Okay, the next shape we're going to look at is a trapezium. Now, what I'm going to do with the trapezium is use the same formula we did right at the very beginning for the area of a rectangle. So what I'm going to do is I'm going to take the sides of the trapezium on this left-hand side, and imagine I cut off that triangle on the bottom right-hand side, and I move it to the top up here, and that would make a rectangle. I'm going to do the same on the other side, and I'm going to cut along here, halfway between this vertex here and this one here, and cut straight down, and I would take this triangle off, and I would move that triangle up to fill in this space. And what that gives me is a rectangle this wide, and it has a height of 6, the same as the original trapezium. Now what I need to do is to find the area of that rectangle, and that rectangle is the same as the area of the blue trapezium, because we've taken this triangle away and tucked it up at the top, and we've taken this triangle away and put it up at the top as well. Now what I need is the length of this rectangle, because we know length times width will give us the area. It's somewhere between 5 and 11, this length, and it turns out it's the average of these two numbers. So the way we find the area is, first of all, we're going to find the average of 5 and 11, and the way we do that is we add them together. So 11 add 5 is 16, and then 16 divided by 2 is 8. So that measurement there, 8, is the distance between this point here and this point here, or the length of that rectangle. It's the average of those two parallel sides, the 5 and the 11. So we added them, we got 16, we divided by 2, that gives us 8. Now we can find the area of the trapezium. It is simply the area of this rectangle, which is 8 multiplied by 6. So 8 multiplied by 6 is 48 square centimetres. Now, students taught by me know this as a rhyme. So half the sum of the parallel sides, so we added the parallel sides and we halved it, times the height between them. That is how you calculate the area of a trapezium. So we add up the parallel sides and we halve it, and then we multiply by the height between those two parallel sides. Okay, let's have a look at an example. So on the left-hand side, I have two parallel sides. They are 4 and 7. Those two sides are going in the same direction. I'm going to find half the sum of the parallel sides. So I'm going to sum or add the parallel sides together. So 7 and 4 is 11. And then I halve that, 11 divided by 2, which is 5.5 or 5.5. So that's the average of those two parallel sides. I've added them together and I've halved it. I then do the average of the parallel sides multiplied by the height between them. So I have 5.5 multiplied by 4. Now I can double it, and that would give me 11, and then double it again. That would give me 4 lots of 5.5, which gives me 22 centimetres squared. So average the parallel sides. We do that by adding them and then dividing by 2. And then we multiply that number by the height between these two parallel sides. So pause it and have a go at the question on the right-hand side. Okay, half the sum of the parallel sides. So the parallel sides here are 3 and 7. So we're going to add them or sum them, and we get 10. Then we're going to find half of that, which is 5. So the average of 3 and 7, the mean of 3 and 7 is 5. Then we times by the height between them. So that's 4. So then we have 5 multiplied by 4, which is 20 centimetres squared. Okay, the next shape we're going to look at is a circle. Now there are two measurements in a circle we need to be really sure of, that we know which one is which. This measurement here from the centre of the circle all the way to the outside, to the circumference, is called the radius. So it's the distance from the centre of the circle to the outside. So I'm going to write radius. Okay, and now we need that measurement to find the area of a circle. Now you're not going to be given this formula, you're going to have to learn it. And the area of a circle is pi, talk about that later, multiplied by the radius squared. And squared means multiplied by itself. So pi is a number that's stored on your calculator. You can find the pi button on your calculator. Sometimes they will guide you to use 3.14. It's a longer decimal than that, 3.1415, and it keeps going. But use the pi button on your calculator. So to find the area of a circle, we're going to do pi multiplied by the radius, which in this case is 4, squared. So at this point, you need to pick up your calculator and you type pi times 4 squared, or if you prefer, you can type 4 multiplied by 4. I'm going to get the calculator. I haven't got my scientific calculator at the moment, so I'm going to use the on-screen calculator. Pi is about 3.14 3.1415 multiplied by 4 squared, and that gives us 50.264. And if you use the pi button on your calculator, you'll probably have a few more decimal places. We want to just give our answer to 3 significant figures. That's the first 3 digits, this much. Now the next number is 6. It's bigger than 5, so we're going to round up. So instead of writing 50.2, because the next digit is 5 or more, we're going to write 50.3. And again, our radius was in centimetres, so that will be square centimetres. Pi, this number on the calculator, multiplied by the radius squared. Okay, so let's have a look at one more example. The formula for the area of a circle is pi times the radius squared. So it's pi, this number that the calculator stores, 3.1415, times the radius, which in this case is 3, squared. Okay, again, you can use the pi button. If you haven't got the pi button, I haven't on this particular on-screen calculator, I'm going to use an approximation, 1415. 926, you can use the pi button on a calculator. 3.14 is usually fine, multiplied by 3 squared. So you can type 3 times 3. I know that 3 squared is 9, so I'm going to multiply by 9. And that gives me 28.274 and a few more decimals. Just like the last one, I'm going to round this to 3 significant figures. So I start at the beginning of the number and I underline the first 3 digits. The next number is a 7, so that's more than 5, that tells me to round up. So I'm going to add 1 to the previous digit, 2, and I have 28.3 centimetres squared. So if you want to pause the video and have a go at the question on the right hand side. Okay, let's look at the question on the right-hand side. So same formula, we're going to use pi times, the radius here is 5, and then we're going to square that number. So 5 squared means 5 multiplied by 5. So I know that 5 squared is 25, so I'm going to do pi times 25. I'll just show you that on a scientific calculator. So here is the pi button here, 3.1415. Now we don't need all those decimals, but you can use the pi button on a calculator to get a more accurate answer. So pi multiplied by 5 squared, which was 25, gives us 78.539. So 78.539. And then one more decimals. I'm interested in the first 3 digits, the 3 significant figures, which is the accuracy most answers are given to. So 78 point, and because the next number is less than 5, we're going to disregard the rest of the number. We don't need to round up, we're going to round it down to 0.5. 78.5 centimetres squared. Okay, now if you'd like to pause the video, there are 6 questions on the screen for you to have a go at. Okay, let's look at some of the answers. So the first one, 6 times 6, and we treat that like a rectangle, that gives us 36. The second question, a triangle, we're going to do the base multiplied by the height, and then we are going to divide by 2. It takes up half of the rectangle that it sits inside. So we have 3 times 3.2 and then divided by 2 gives us 4.8. This time the measurements are in meters, so our answer is in meters squared. The third question is a parallelogram. We treat that just like a rectangle. It's just base multiplied by height. So that one would give us 37.44. If you rounded it to 3 significant figures, you'd have 37.4, and that's in meters squared. Okay, the next one is a trapezium. So if we have a look at the fourth one, we have to identify the two parallel sides, the two going in the same direction. So that's 3.3 and 7.5, and we add those together and divide by 2. We find the average of the parallel sides. So 7.5 add 3.3 divided by 2 is 5.4. So we multiply the average of these two sides by the height, which is 9.5, and that gives us 51.3 millimeters squared. The next one is a circle. We use the formula for the area of a circle, which is pi times the radius squared, and the radius is a measurement from the center to the outside, which is 4.9. So in this case, we have pi times 4.9 squared, which gives us 75.4. Okay, and the last one is also a circle, except this time we're given the diameter, which is the distance from one side of the circle to the other, which is 19.4. We need the radius for our formula, so we have to take 19.4 and divide by 2 to get the radius, which is 9.7. Pi times our radius squared, pi times 9.7 squared is 295.592. And if we round it just like we did before, we will get 296 centimeters squared. Okay, now for those of you who are at school with us, you are working from resources on SharePoint. This is what you see when you open the Year 10 folder for sets 2, 3 and 4. If you go into task 3, you can find the worksheets that are linked to this task. They look like this. You are working on pages 38 and 71, perimeter and areas of circles. And if you have any trouble or any questions, do please get in touch with us at school.